Hello, very good morning student. Today again we can continue our topic of physics, that is the gravitation. Okay, so again we can come to the new topic, new session after completing your all the that is topics of your surface tension, system of particles, rotational motion. Okay, now we can start the gravitation in case of that physics. Okay. So, the first of all, we have to learn some terms before directly starting with the gravitation. Because what is exactly meaning of gravitation? Gravitation क्या है? Okay. So then actually we want to start that Newton's law of gravitation. Okay. Because the gravitation itself is because of when the apple falls on the ground, then the question arises. That means the question arises to Newton why the apple falls on the ground only, and then it will be the starting of the gravitation. So now, but sir, what is gravitation? So only what the apple falls on the earth's surface, so only that is the gravitation? No. Gravitation means any body in the universe attracts to every other body. Means the body which have the mass, and then this body, one mass is attracted towards the another mass. Okay, so that is also called as the gravitation. Okay, so therefore we can say that the force of attraction between any two bodies, okay, or two matter particles in the universe is called as the gravitation. Okay, so then now that question is very clear. Gravitation means that any body, or that means in the universe, that matters which have the mass, okay, then that one mass is attracted towards the another mass. So that is the two. So for example, if you can take the question of sun and earth. Sun has the mass, earth has the mass, so therefore there will be a force of attraction. So that is also called as the gravitational force. Okay, you remember that things. So that means attraction between the sun and the your earth. So that is also called as the gravitational force. Or we can also say that when the earth, that satellite is revolving around the earth, satellite have the mass, earth have the mass, so therefore there will be the force of attraction. So that is also called as the gravitation, and the force with which the body attracts, one body attracts towards the another body, that is called as the gravitational force. Okay. But now question arises, sir, so this force is particularly, or this gravitation is particularly related with the masses. Sir, what is exactly mass? Mass हम किसको बोलते हैं? Mass means quantity of a matter possessed by the body. Okay, means whatever the any body. Suppose here I am standing in front of you. Whatever the quantity of a matter which I have possessed here, so that is called as the mass. Okay, or if this body. So what is the quantity of a matter possessed by this body? That is called as the mass. Okay. So now, if this is the mass, then question arises. This mass can be measured in kg in SI system or gram in CGS system. Okay, and your dimensions of the mass are m1, l0, t raised to 0. So you know very well. Okay, so now length, mass, time. Mass is one of the fundamental quantity that also you remember. Okay, but quantity of matter possessed by the body, that is called as the mass. So then now what is weight? Okay. So weight means the force with which any body is attracted towards the earth's surface. So that is called as the weight. Okay, force with which a body is attracted towards the center of earth is called as the weight. And the unit of the weight is Newton. Okay, weight, that means weight measures in Newton in SI system, or it is measures in time in CGS system. Actually, if you are multiplying that m with g, so then that will becomes weight. Okay, only just, and the weight depends upon gravity. Place to place it is going to get changed. Okay, so that you remember. So then now question arises, sir, what are the dimensions of the weight? So as this is the force, okay, so therefore m into g, so m1 l1 t raised to minus 2. So this, therefore the dimensions of that your weight, that force will be, that is m1, yeah, okay, mass into, that is the g acceleration l1 t raised to minus 2. Okay, once you got the idea about mass and weight, so only these are the only points about the mass and weight. Mass is the quantity of matter possessed, and weight is the force with which the body attracts towards the center of earth. No, we can say there are some distinguished points are also there in between the your mass and weight. Okay, so which are the distinguished point? If I just write down mass and weight, if you are making two columns, and then you can start writing that definition, or that means your distinguished points between the mass and weight. So we can say like this, okay, mass is particularly scalar quantity. It is the scalar quantity. While weight, it is the vector quantity. Why this is vector? Because it is a force. It depends upon g. G is the acceleration due to gravity. Anyway, this is the gravity, but due to that means acceleration due to gravity. So therefore, it is a vector quantity. Okay. Second point, sir, definition. What is the mass quantity of a matter possess? Quantity of matter. Okay, quantity of matter possessed by the body. And what is that weight? Weight is the force with which the body attracts towards the center. The next point, the mass and weight. Okay, so the next point, mass can be measured by beam balance. Beam balance. While weight can be measured by using the spring balance. Okay, so that is also one of the important point. Okay, spring balance, you know the principle. Force is directly proportional to L. Means if you are applying, if you want to measure the weight of the body, you can just hang over to that body, to that your spring, and the spring is going to get elongated, and so larger the weight, larger will be the elongation of the spring. That is the spring balance. And big balance, you can measure the mass of that particular body. Okay, so now mass cannot be zero. It will be never zero. Mass cannot be zero. Okay, because it has the quantity of a matter possessed. But weight can be zero. Weight can be zero. Where the weight can be zero? Can you tell me, students? Where that as the weight is the product of mass into acceleration due to gravity, where the gravity is zero, that time it will be that weight can be zero. So where the weight, that gravity will be zero, at the center of earth gravity can be zero, so therefore weight of the body can be zero at the center of the earth, so that can be the weight. So mass can be, SI unit of mass is kg, it is measured in kg, while SI unit of weight, it is measured in Newton. Okay, so as it is given by the Newton, so therefore its name has been given. Weight is, this is the force, and which is measured in Newton. CGS unit of mass will be gram, while CGS unit of your weight is dyne. Okay, weight and dyne. The dimensions of your mass can be m1 L0 t raised to 0, while weight can be m1 L1 and t raised to minus 2. Okay, so mass into acceleration. Acceleration will be L1 into t raised to minus 2. So therefore that can be a weight. So these are the different points which we can say, these are the distinguished point between mass and weight. Okay, you just remember that points. Once you got the idea about this, that mass, weight, okay. Again, before proceeding to that Newton's law of gravitation, you should know the four fundamental forces in the universe. Okay, so which are the four? There are the different types of forces are there, but the fundamental four forces are there. And these forces are, types of forces are, first is gravitational force, second is electromagnetic force, third is the nuclear force. Nuclear force can be further classified into strong nuclear force and weak nuclear force. So therefore, how many fundamental forces are there? Four forces are there: gravitational, electromagnetic, strong nuclear and weak nuclear force. Okay. So then now, sir, what is exactly gravitational force? Okay, so actually you have learned that all the fundamental forces in the universe, in the physical world and measurements. Okay, when we have started the chapter physical world, that time already you have learned that four fundamental forces in the universe. So now, but just before proceeding to that, I will just give the idea about that all the four forces, and then we'll start the Newton's law of gravitation. So what is the gravitational force actually? Actually, the force of attraction between any two masses, okay, which is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. So that force is nothing but the gravitational force, or the force which exists between the two masses. So that is called as the gravitational force. Okay, if I will say, sir, what is that gravitational force? First force, fundamental force in the universe, gravitational force. Okay, so that force which exists between two masses, okay, any 2 point masses. So now any 2 point masses means m1 and m2. So these are the 2 point masses. What do you mean by point masses? The separation of the distance between two masses should be very large as compared to their radii, then that is called as the point masses. Okay, so therefore, so that gravitational force, we can say that the force of attraction between any two matter particles in the universe is called as the gravitational force. Okay, so what are the properties of that gravitational force? Okay, what are the properties of gravitational force? So now if I want to see the properties of that gravitational force, okay, here that force will be according to Newton, so that we are going to come to the next later on. F is equal to G m1 m2 upon r square, so that will be the your force. The properties are of that gravitational force, it is the weakest force in the universe. So what is the important property? This is the weakest force in the universe. Okay, weakest force. Okay, this is the always attractive force. That force is always attractive force, means any mass will be always attracted towards the another mass with that force, and that force is nothing but the gravitational force because it has the masses. Third point, we can also say that it is the long range force. It is the long range force. Okay. And moreover, there are so many other properties also. We are going to come to that point while you are learning the Newton's law of gravitation or that properties of the gravitational force. But this is the all about the gravitational force. Now, sir, what is the electromagnetic force? Okay, second force which we can say, that is all about the electromagnetic force. Okay, sir, what is electromagnetic force? So electromagnetic, or this is also called as electrostatic force and the electromagnetic force. Okay, because this force which exists between the any two charged particles. Okay, whether the charged particles are the stationary, then that is the electrostatic force. If they are in motion, then that is the electromagnetic force. Okay, you just remember that. Electrostatic force means where the Newton he has given the, that is law for the two masses, then that time the new, that means your Coulomb has given the two, that means force of attraction between the two charged particles. So that is Q1 and Q2. If these are the two charged particles which are separated by the distance r, then now that force which exists in between the two particles, so that is the, we can say that Q1 Q2, but that will be 1 upon 4 pi epsilon 0 Q1 Q2 by r square. So when that is the constants of proportionality, epsilon 0 is the permittivity of free space, Q1 Q2 are the charges, and r is the separation of the distance between the two charges. Okay, they are always measured from the center. For that, this is also center force, always measures from the centers. Okay, you just remember. So then, sir, what are the properties of that electromagnetic force? Okay, which are the different properties of electromagnetic force? Okay, first time, the first property is this force is attractive as well as repulsive. Attractive as well as repulsive. When it will be the attractive, you know? Students, can you tell me when they will be attractive? When there will be dissimilar charges. One is positive, one is negative. Then there will be always attraction. Plus Q minus Q. They will be attracted with each other. So that will be the attractive. As well as it will be repulsive also. Repulsive. When it will be repulsive? When they will be same charge. When these two charges are similar, then they will repel with each other. Plus Q minus Q minus Q. Okay, so therefore there will be a force of repulsion. So therefore attractive as well as repulsive. This force is stronger than gravitational force. You remember, okay? It is stronger force. It is stronger force. Okay. How much it is stronger? It will be near about 10 raised to 36 times stronger than that of the gravitational force. Okay, you remember 10 raised to 36 times. Okay, stronger. Okay, than gravitational force. Than gravitational force. Okay. Third is here, this is also long range force. This is also long range force. Okay, so these properties also possessed by the electromagnetic force. Okay, once you got that, these two forces, the next force which we can come to the point is the nuclear force. So that which is that type of force, that is the nuclear force. Well, you are talking about the nuclear force, so that force itself is defined. So what is that exactly? Nuclear, strong nuclear force. We can say first strong nuclear force. Okay. So what do you mean by strong nuclear force? The force which exists between any two protons or any two neutrons or proton and neutron inside the nucleus. So that force is called as the strong nuclear force. It's here itself, its name indicates this force is related with the nucleus. And what is there inside the nucleus? You know what is the atom? Smallest particle of the substance which cannot be further divided, that is called as the atom. And inside the atom there is a nucleus, and in that nucleus there are the positively charged particles are called as the protons, and the neutral particles which can call as the, what we can say, that protons and neutrons. Okay, and the electrons are revolving around the nucleus, so that electrons are not involved into that nuclear force, only in between protons and neutrons. Neutrons are uncharged particles. Okay, but this force always comes in pair, either between two protons or proton and neutron, or neutron neutron. Okay, in between that, this is the charge independent force. This is a very very important property, because in between the two neutrons also this force exists. Okay, so then what are the, that means your properties or characteristics of this strong nuclear force? Properties of strong nuclear force is the, it is the short range force. It is short range force. Means here it exists between the only inside the nucleus, and you know the size of nucleus 10 raised to minus 14 to minus 15 meter. So that is femtometer. This is the size of nucleus, and in between that this force can be exist. Okay, it is the strongest force in the universe. Okay, it is the strongest force in the universe. Okay, so how much it is the strongest? That is the 10 raised to 38 times greater than, 10 raised to 38 times greater than which one? Gravitational force. Than gravitational force. Okay, so that is also very very important property of that your that is your strong nuclear force, but it is the 100 times, means 10 raised to 2 times greater than the electrostatic force or electromagnetic force. Okay, you just remember that points. Okay, so now this will be always attractive force. Okay, this is also attractive force. Okay, but up to certain distance, bachche log. Okay, up to certain distance it will be becomes attractive. Later on it will also trying to becomes the, with the same magnitude 10 raised to 38 times repulsion also, when that any particle is which is very very near to the nucleus, so then that time it will becomes repulsion also, but basically it is the attractive force. Okay, so it is a short range, it is the again your attractive force. Okay, and it will be the strongest force, but it will be the short range force. And what I have explained, it is the charge independent. Okay, charge independent means it does not depends upon the charge. जैसे वो इलेक्ट्रोमैग्नेटिक फोर्स चार्ज के ऊपर डिपेंड्स करता है बच्चे लोग, वैसे वो स्ट्रॉन्ग न्यूक्लियर फोर्स कभी भी ये चार्ज के ऊपर डिपेंड्स करता नहीं है. So that is the strong nuclear force. And last but not the least, that is the weak nuclear force. Okay, that is also one of the fundamental force in the universe. And so what is the weak nuclear force? The force which is also, that means exist inside the nucleus only. Okay, but now this force is particularly exists between the electrons or that your positron, or we can say that electrons and the neutrino, and positron and antineutrino. Okay, in between that whatever the force exists, so that is called as the weak nuclear force. Actually this force exists when there are some radiations which are coming out from the nucleus, like as alpha, beta, gamma radiations when come out, so that is also called as alpha decay, beta decay, gamma decay. Okay, and you know when the beta particles comes out from that nucleus, so then at actually that electrons, that means your neutron is going to get split up and electrons comes out, and along with that electrons, so there will be the, that is the anti-neutrino or neutrino. So these are the particles are there, so they are coming out, and in that between, that means these particles, there is a force exists between the electrons and the, that is your neutrino or positron and the anti-neutrino. So that force is called as the weak nuclear force. And the properties of that weak nuclear force is, again we can say that this is also short range force. This is also short range force. Moreover, it is stronger than, it is stronger than gravitational force. And how much times, 10 raised to 25 times. It is stronger than gravitational force. Okay, gravitational force by 10 raised to 25 times. Okay, remember. But it is not a stronger than strong nuclear force. Okay, it will be weak, means the strong nuclear force and the your gravitation electromagnetic force are the stronger than that of that your weak nuclear force. You just remember that things. Okay, so now once you got that short range force, it is again the strongest force. Okay, 10 raised to 35 25 times it is greater than that of the gravitational force. So these are the some important properties which can exist for the weak nuclear force. Once you got that things, so now sometimes they can ask you a question about what is the weakest force in the universe. So that will be the gravitational force. If I'll say gravitational force is the one, then next force will be the, that is the weak nuclear force. So that is the 10 raised to 25 times. Then the कौन सा अलग तो चलो, that is the electromagnetic or electrostatic force. Okay, so that will be 10 raised to 38 times stronger. And last but not the least, that is the strong nuclear force, and that will be 10 raised to 38 times stronger than that of the gravitational force. Okay, so this is the your ratio, 10 raised to 36 times. Here this is electrostatics, and 10 raised to 38 times, that is the strong nuclear force. Okay, so these are the, that means your the characteristics or relative strength of that force. Okay, gravitational is related with the mass, electromagnetic force is related with the charge, nuclear force is related with the nucleus. Okay, so then now we can start the Newton's law of gravitation. Okay.